Welcome to CIS 201, Section 1, Introduction to Database Systems. Introduction. Welcome to the course CIS 201, aptly called Introduction to Database Systems. The course will be taught over a series of studies or lectures examining various concepts as itemized in the table of contents. During this study, you will learn the basic concept of data and information and their means of storage. We will be focusing on the various options for storing data such as file and database systems, their similarities and differences, and the advantages of one over the other. In the long run, you will be able to understand the various components of the database systems which make it possible to effectively house data. You will also learn about the database management system, a major software component of this database system environment, and highlight its functions and advantages which facilitate the management of databases. Learning outcomes. At the end of this study, you should be able to 1. Discuss the concept of data and information storage. 2. State the similarities and differences between file systems and database systems. 3. Explain the database management systems and its functions. Data and information. Data is defined as raw or unprocessed fact. Information is the result of processing data. Processing could involve several activities such as grouping, extraction, and summarization of the unprocessed fact data. Organizations generate vast amounts of data from their daily operations, and in order to ensure their efficient running, organizations must be able to store such data for various purposes ranging from processing to decision-making. For instance, a manufacturing company producing soft drinks and beverages wants to improve sales. Such a company could go on to have the record of sales of their two major products, beverages and drinks, over a period of time, say 2 months. The details collected at this stage will be referred to as data because it is yet unprocessed and is therefore not useful for the required purpose. See Figure 1.1 and 1.1a. In order to draw any meaning from this data, there may be need to group the sales record according to the product, sort the sales in descending order, starting from the highest sale amount, or arrange sales in clusters of their periods, weeks, months, years, etc. Having done that, it is easier to see which of the products made more sales and at what period of time were sales generally higher or lower. This will help the firm make concrete decisions in order to improve their net sales. The data obtained in Figure 1.1a is processed by grouping according to the type of product and sorting them by date from the latest to the oldest, and sorting in order to have the information in Figure 1.1b. For an easier view of the product with the higher sales, how do you think the table can be solved? Table A says data unprocessed. Table B says data processed. The need to process data for easy storage, retrieval, and reporting is a major motivation for database systems. Therefore, in the rest of this study, you will examine some other motivations for databases as well as an understanding of what databases are and what they are not. File system. File system refers to a data storage mechanism which stores data in files organized in a tree-like hierarchical structure. Therefore, to access a file, you must access its parent file, and the deletion of a file implies the deletion of all its child files. Just like files are managed, stored, retrieved, created, and deleted within a file system, databases are managed by a software called Database Management Software, DBMS, which you will learn in 1.3. Figure 1.2, here is a folder full of files. For us to understand the need for databases, let us consider the following scenario. A large organization has a large collection, say 800 gigabytes of data on their employees, departments, products, sales, etc. And this data is accessed simultaneously by several employees. Questions about the data must be answered quickly. Changes made to the data by different users must be applied consistently, and access to certain parts of the data, e.g. salaries, must be restricted. You can try to deal with this data management problem by storing the data in a collection of operating system files. As simple as this approach seems, it has many drawbacks, some of which is highlighted as follows. You probably do not have 500 GB of main memory to hold all the data. Therefore, you must store data in a storage device such as a disk or tape and bring relevant part into main memory for processing as needed. Even if you have 500 GB of main memory on computer systems with 32-bit addressing, you cannot refer directly to more than about 4 GB of data. Therefore, you have no program, some methods of identifying all data items. You have to write special programs to answer each question that users may want to ask about the data. These programs are likely to be complex because of the large volume of the data to be searched. You must protect the data from inconsistent changes made by different users accessing the data concurrently. If programs that access the data are written with such concurrent access in mind, this adds to their complexity. When system crashes occur while changes are being made to data, you must ensure that data is restored to a consistent state, that is, the changes are either completely affected or completely reversed. Operating systems provide only a password mechanism for security. This is not sufficiently flexible to enforce security policies in which different users have permission to access different subsets of the data. These issues reveal to us the drawbacks of the file system, which makes it unsuitable for storing large amounts of data for easy retrieval, maintenance of data integrity, and enforcement of data security. From what you have seen above, quickly identify some of the drawbacks of the file system that motivate the need for a DBMS. Drawbacks of the file system. The following are drawbacks of the file system. 1. Structural dependence. A file system exhibits structural dependence, that is, access to a file is dependent on its structure. For example, if the information in Figure 1b was stored in a file and the program that accesses it reads each feed column of the table of the file and writes it to output accordingly. Assuming you now had a product in the feed to the file, you would have to make provision for this in our program. Therefore, all of the file system programs must be modified to conform to the new file structure. In short, because the file system application programs are affected by change in the file structure, they exhibit structural dependence. Conversely, structural independence exists when it is possible to make changes in the file structure without affecting the application program's ability to access the data. 2. Data dependence. Changes in the characteristics of data, such as changing a feed from integer to decimal, require changes in all the programs that access the file. Because all data access programs are subject to change when any of the file's data storage characteristics change, that is, changing the data type, the file system is said to exhibit data dependence. Conversely, data independence exists when it is possible to make changes in the data storage characteristics without affecting the application program's ability to access the data. 3. Data redundancy. Data redundancy occurs when the same item of data is stored unnecessarily in different places. Data redundancy possesses a number of problems in data storage. A. Data inconsistency. This occurs when you have different conflicting versions of the same item of data stored in different places. For instance, changing the product rate in the product file without changing it in the sales file shown in Figure 1.1 shows inconsistency in the same data item stored in different places. B. Data insecurity. The security of the data in the storage can be compromised when there are possibilities of unauthorized access to some copies of data due to data redundancy. C. Data anomalies. Data anomaly is a condition of abnormality in operations carried out on data, and this is caused by data redundancy. There are insertion anomalies, update anomalies, and deletion anomalies. 4. Lengthy application development time and extensive programming. As seen under structural dependence, making changes to file structure in a file system often requires extensive programming, and the overhead is lengthy application development time. One of the most glaring problems with the file system approach is that even the simplest data retrieval task requires extensive programming. With the older file systems, programmers had to specify what must be done and how it was to be done. As you will learn in upcoming studies, modern databases use a non-procedural data manipulation language that allows the user to specify what must be done without specifying how it must be done. 5. Lack of design and data modeling skills. A new problem that has evolved with the use of personal productivity tools such as spreadsheets and desktop databases is that users typically lack the knowledge of proper design and data modeling skills. People naturally have an integrated view of the data in their environment. For example, consider a student's class schedule. The schedule probably contains the student's identification number and name, class code, class description, class credit hours, the name of the instructor teaching the class meeting days and times, and the classroom number. In the mind of the student, these various data items compose a single unit. If a student organization wanted to keep a record of the schedules of all of the organization members, an end user might make a spreadsheet to store the schedule information. Even if the student makes a foray into the realm of desktop databases, he or she is likely to create a structure composed of a single table that mimics the structure of the schedule. Database systems. A database is an organized collection of logically related data for efficient storage, management, and retrieval. Database systems are managed by software called Database Management System (DBMS). Databases have become an integral part of our present-day world. Every time you visit websites such as Google, Facebook, Yahoo, or Amazon, you type in certain requests or click certain button and menu controls, you are simply retrieving data from some database. Somehow, these systems have become very central to our daily living. The need to study databases which are behind the scenes of their operations have subsequently become necessary. Unlike the file system which stores unrelated data within the same structure, databases seek to organize data in some logically coherent way, even though such data may be distributed within various physical units. Figure 1.3 Contrasting database and file systems. Focused database systems will help highlight its improvements over the file system, their similarities and differences. As shown in Figure 1.3, access to all the contents of a database system is managed and controlled by the DBMS, thus allowing data to be stored in a single logical unit while specifying permissions that allows users authorized access to different portions of data by different users. The database systems environment. The database systems environment explains the different components and actors in a database system, ranging from the data actually stored in the system to the various types of human professionals who are responsible for managing the database through the DBMS. Here you will learn about each component and actor with details of their roles in the database system. 1. Data. This is the fact actually stored in the database. Data could be of various types: integers, decimals, objects. 2. Software. Although the DBMS is the most notable software needed in a database system, other software such as the computer operating system and other application and utility programs such as interactive graphical user interfaces (GUI) allow users to submit their queries and generate reports in very easy and interactive ways. 3. Hardware. These are the physical devices and resources responsible for housing the database. This includes disk drives, which are the actual physical locations of the database, visual display unit, keyboards for entering input, etc. 4. People. There are various individuals who use the DBMS: end users, application programmers, database administrators, and system administrators. Advantages of database systems. As opposed to the file system, databases offer a good number of advantages for data storage, management, and retrieval courtesy of the DBMS. Many of these advantages are simply the opposite of the drawbacks of file system discussed in section 1.2. 1. Data independence. Database systems allow application programs to be as independent as possible from details of data representation and storage. The DBMS provides an abstract view of the data to insulate application code from such details. 2. Data integrity. If data is always accessed through the DBMS can enforce integrity constraints on the data. For example, before inserting salary information for an employee, the DBMS can check that the department budget is not exceeded. 3. Data security. The DBMS can enforce access controls that govern what data is visible to different classes of users in order to prevent unauthorized data access, while it also ensures that authorized users are not denied access. 4. Efficient and easy data access. A DBMS utilizes a variety of sophisticated techniques to store and retrieve data efficiently. This feature is especially important if the data is stored on external storage devices. 5. Reduced application development time. Clearly, the DBMS supports many important functions that are common to many applications accessing data stored in the DBMS. This, in conjunction with the high-level interface to the data, facilitates quick development of applications. 6. Concurrent access. A DBMS schedules concurrent accesses to the data in such a manner that users can think of the data as being accessed by only one user at a time. 7. Crash recovery. A DBMS protects users from the effect of system failures and crashes by ensuring that the database recovers from system failures and restores data in it to a consistent state. The Database Management System. Database Management System (DBMS) is the software that manages data systems. Figure 1.3a shows a typical structure of the DBMS, including different categories of people who use the system. Examples of some common DBMS are Oracle, Microsoft SQL Server, MySQL, and DBase2. Figure 1.1a Structure of a DBMS. DBMS functions. Some functions of the DBMS include 1. The management of data storage is one of the responsibilities of the DBMS. This is to ensure that data is efficiently stored for easy retrieval. This is achieved through the data dictionary, in which the DBMS stores details of data and their relationships. 2. The DBMS facilitates data retrieval and report generation by transformation and presentation of data in appropriate formats. 3. The DBMS ensures security of data by allowing user access permissions to be specified so that different classes of user are allowed authorized access to different portions of data, hence denying unauthorized user access. 4. The DBMS is also responsible for concurrent user access to data. 5. In case of system failures and crashes, the DBMS ensures that data is not lost by promptly backing up data for system recovery purposes. 6. The DBMS helps manage data integrity by specifying constraints and rules guiding operations on data, insertion, deletion, update, retrieval, etc. 7. The DBMS also provides a database access language known as Structured Query Language (SQL) for accessing data in the database and application programming interfaces (API) for application programs to interact with the database. It is obvious from these functions that many of the advantages offered by database systems are provided by the DBMS. Hence, the DBMS is seen as the backbone of a database system. Summary. As we conclude this study session 1, you are expected to have learned 1. About data and its transformation into information. 2. About the legacy storage system, file system, and their drawbacks which motivated the development of the database system. 3. To be able to compare and contrast file system and database system. 4. To understand the advantages of file system over database systems while also appreciating the need for database system. 5. The various components of the database system environment. 6. The importance of DBMS to database systems. In the next study, you should take a look at the available data models. This is the end of study section 1. Thanks for listening.